So now let's take all the definitions and scripts for the regression model and let's apply them to a real problem. Now we've already seen this data set. This is the relationship between fertility rates and life expectancy for all the countries in the world in 1962. So we want to explain the meaning of the slope in the context of the situation, and remember to include units. All right, so slope. When you look at this is actually written in the algebra way. The slope is the one that's with the x, right? That's slope. So it's right here. It's always the one that's next to the x variable. Okay, so what is the slope and how do we interpret it? So we want to explain that meaning. So first I'm going to just write it real quick. So the slope was negative 4.6711. There we have it. All right, so let's use the script. So the script was a couple pages ago. It says if x, which is in words, increases by 1 x unit, then the y is expected to increase or decrease by approximately a units. All right, so I'm going to write that script up with some blanks and then we'll fill it in. Okay, it's a script with a lot of blanks, but let's see if we can fill them out. Now, when you get a problem like this, one of the most important things you can do right off the bat is to label your variables. So fertility rate is the x. This is the x-axis. And so this is your x unit in parentheses. It's very common for the units to be in parentheses next to them. So when it says if, and then we're going to write the x right here in words. So the x was fertility rate. So if fertility rate, or if the fertility rate increases by 1 unit, right? This will be the x unit, which is births per woman. Then the y, well, the y is the other variable. So right here is the y, the life expectancy. And then right next to it in parentheses is the y unit. So down here for our script, we would say then life expectancy, right? That's the y in words, is expected to something. Okay, so we have to choose increase or decrease. Right here is an increase or a decrease choice. So increase if it's positive, decrease if it's negative. So let's look at our slope. Our slope is a negative number. You can tell that by looking at the graph. So therefore, we're going to use the word decrease. It's going to go down by whatever the slope was. The slope was negative 4.6711. Oh, but we won't actually say the negative. We already said the negative when we said the word decrease, so we don't actually have to write the negative here. And the y unit was years. So this is the y unit, and right here goes the slope. It's really the slope number, whatever that number might be. The positive or negative is taken care of by the word increase or decrease. So let's think about what this is saying. If you have a country where the fertility rate goes up, then the life expectancy goes down. Right? The higher they have, higher they are in fertility, the more births per woman they have, the lower that life expectancy. And we're just quantifying with the 4.6711 and the 1 actually, how that ratio works. Okay, now explain why the y-intercept does not make sense in this situation at all. So first let's look at what the y-intercept is. The y-intercept is 0 comma this number. This number alone is not the y-intercept, but it's the one that's sitting off by itself without the x next to it. So this y-intercept would be 0 comma 81.51. But the 0 doesn't make any sense because the 0 would mean you have a country where nobody is having children, right? There are 0 births per woman. That's a science fiction movie called Children of Men with Clive Owen. I highly recommend it. It's a good movie, but it's not possible, impossible for a country, right? This is our script, right? For explaining when it doesn't make any sense, right? It's impossible for, and then we're going to talk about what x equals 0 would mean for a country to have zero fertility, right? That would mean there are no births per woman in the whole country. And that is unrealistic and impossible. Okay, so what about the US? The US had a life expectancy of 70.21 years in 1962. Calculate the expected fertility rate back then. Ooh, okay. So let's read very carefully. The United States had a life expectancy of 70.21. So if we go back to our graph and we look, life expectancy is Y. So we're saying, hey, Y was 70.21. Calculate the expected fertility, but fertility is X. So what we're saying is use your equation. Use the equation that was given. I'm actually going to write it in the stats way, which would put the 81.51 minus 4.6711x. Right? That's the standard way of writing it in statistics. This is more the algebra way. It's fine either way if you're comfortable either way, but I'm going to write it more the statistics way because that's the way we use it more often. So what they're saying is put the 70.21 in over here for y. So 70.21 equals 81.51 minus 4.6711x. Okay, the first thing we want to do if we want to solve this for x is we need to get rid of this 81.51. It's gumming up the whole process. So we're going to subtract 81.51 from both sides. That'll leave us over here, these two will cancel because 81 take away 81 is gone. So over on the right hand side, we're going to be left with negative 0.46711x. That's multiplication, by the way. In mathematics, whenever we put a number next to a variable like that, it's multiplication. And the shaking of the screen was my dog kicking the desk underneath which I'm making these videos. Sorry about that. Okay, so let me go grab Desmos. And I want to get rid of these problems. So I want to take 70.21, take away 81.51, and we get negative 11.3. So over on this side, these two numbers get us a negative 11.3. Okay, now this is multiplication. To undo this, you need to divide. Over here, it divides to nothing because 4.6 divided by 4.6 is 1. So that's all gone. So I just need to know what this number is. Okay, so let me go grab Desmos. Negative 11.3 divided by negative 4.6711. And for the record, it actually doesn't matter if the negative is here or here, right? It can be out in front or it can be up on top. Either way, you're going to get 2.419. That'll be your x. Okay, so let's think about what that means. That would mean the fertility rate for the US was 2.42 births per woman, right? That would be the unit because this was fertility rate for the US back in 1962. So we were expecting women in 1962 to have roughly 2.4 children over the course of their lifetime. For the record, if you're thinking, well, you can't have 0.4 of a kid, that's true. It's not really about any one woman. It's about how it averages out for the whole, right, for the entire population. That's what we're really talking about.